Greetings. Admittedly, evolution isn't an easy idea to grasp because the time and scale of it boggles the mind. It's hard to think that a fish evolved into a reptile-like creature, which in turn evolved into a mammal, that evolved into a primate, and then to us. For most, it's probably easier to imagine evolution as stepping stones, where a species just appear, but this isn't the case. All species are in a continuous state of change. One analogy is like watching someone grow old. The change happens so gradually and there's no definition of what being old looks like. You can easily see the change in hindsight. Imagine your grandmother had someone take a picture of her every morning from the time she was 12 until she was 80. You find the pictures and start flipping through them. None of them are dated and you don't know when your grandmother was born. You could probably separate them into basic age categories like teens, 20s, 30s, etc. But your decisions are subjective since you don't know what day each photo was taken. What if I asked you what day she looked like she was 40 years old? You might be able to take a stack of photos that represents a year or so, and say at the beginning of the stack she didn't look 40, and at the end she did, but you wouldn't be able to pick an exact day because the differences from one day to the next would be imperceptibly subtle. This is exactly how evolution works. Organisms are continuously evolving, like we are continuously aging. If we had a complete fossil record of every generation of organism from the beginning of life until now, we would have a hard time drawing a line between species. They can classify animals into species like we can classify how old we look. The fossil record is our photos, and we only get a snapshot every few thousand or million years or so, and from this we can fill in the blanks. You might have noticed that this image has been slowly evolving. Starting with Homo habilis, it evolves into Homo erectus over the simulated course of 500,000 years. If we say one generation represents 20 years, then the simulation covers 25,000 generations. This morph is composed of 1,500 individual images, which means each one is equal to 16.7 generations or 333 years. If I compare two images, the differences are pretty much impossible to see. How would I go about and tell at what point Homo habilis is no longer a Homo habilis and is now Homo erectus? It'd be impossible to draw a line between two images that represent a gap of 16 generations, much less between parents and their kid, and say this child is Homo erectus and the parents are Homo habilis. Now you might wonder, if one species seamlessly evolves into another, how do we distinguish between the two? Like the analogy above, where we arrange grandma's photos into age categories like teens or 20s, we can generally classify species the same way. But for current species, this is an issue and has been termed the species problem. Wolves and coyotes are a good example. They are very similar and can even interbreed, but we consider them to be different. These two species that have, in geologic timescales, only recently begun to diverge, perhaps their paths will vary significantly, and in 20 to 30 million years they may be as different as the horse and the rhino. Now, I wish I could elaborate more, but this is really just an introduction, so you can visualize how gradual this process actually is. If you have any questions, there are plenty of great videos that explain all aspects of evolution.